Absorber column. Dynamic simulation with controllers.
The process flow diagram of the case presented is shown and briefly described. Two links are used to set up and control the absorber feed streams. Each link is formed by two pipe segments which include one control valve. Two other links define the top vapor product and the bottom liquid product.
Let's have a look at the input data of the problem.
The problem is defined by using 6 normal hydrocarbons from methane to n-pentane for the gas feed, whereas the liquid solvent used is n-octane.
Thermodynamic methods are also defined, PR for equilibrium K values and LK for thermo and volume properties. Let's have a look at the input data used to characterize the initial status of the absorber ABS1. The column has 20 trays. Trays are numbered from top to bottom. The steady-state simulation of the column is calculated using a top pressure equal to 4.0 bar. An initial estimate is defined for product streams. The profile statement provides the initial estimate for column temperatures, pressures, liquid and vapor flow rates, and the initial holdup of liquid on each tray. The column is divided into 4 mechanical sections: top, bottom, trays 1 to 10, and trays 11 to 20. The first section of trays 1 to 10 has a diameter of 2.150 m, and the second, trays 11 to 20, has a diameter of 2.50 m. To catch the values of the various process variables, temperature, pressure, compositions, etc., 18 instruments, located on trays 1, 10, 20, and 21, are used. Tray 21 identifies the bottom section below the last tray. 2 analyzers are located on tray 1 to measure the composition of the light and heavy hydrocarbons in the gas product. Two control blocks are defined. The first is a pressure controller of the absorber's top pressure set at 4.0 bar. The second is a level controller of the liquid in the bottom section set at 0.8 m. The simulation time interval is defined to be 2 hours, the initial time step is 0.2 seconds, the minimum is 0.02 seconds and the maximum 1 second. The interrupt or wait time is set at 20 minutes. The sample interval for instruments is set to 1 second, the trend interval at 30 minutes, the update frequency of the unit operation's internal profile, pipelines or columns, is defined to be 30 seconds. The simulation is now started and the plant view window is created. The instrument bar page 1 is shown. There are 48 instruments that are placed in 8 pages grouped by 6. The calculation is advanced of the first time step and afterward continued. The instrument view is then changed to the trend view and trend pages are browsed sequentially. The calculation will stop when 20 minutes are reached. The trend view of the controllers is shown. A look is given to the column internal profile as defined in the plot input statements. The second wait point at 40 minutes is then reached. A look is paid to the events view. To the column internal profiles. Finally, the simulation is continued. The recording does not show a few minutes. We are approaching 1 hour when the simulation will wait. After the next start, the gas flow rate will begin increasing by 20% in 5 minutes. The user can browse the trend graphs of the various instruments to see how the controllers are reacting to the change. After a final look at column internal profiles. The simulation is stopped. And the plant view window closed. All generated graphs can be previewed and saved as a single file. Final internal column profiles are displayed. Controller's history is available. Data of all instruments is available. Tray 1 temperature, light and heavy hydrocarbon composition. Process variables at tray 10. Process variables at tray 20. and total column pressure drop.